Hi, good morning, everyone. I'm back. So we are going to talk about the other portion of the cell physiology. That is this one here. All right. So this is about cellular division. We basically will talk about how cell divided from a single like fertilized egg and to become like whole body. So that process, that concept. So before we talk about that, we need to talk about the cell cycle. Cell life has a cycle. Cell cycle is already, it's very common across the whole cells in the body. And these cell cycles contain interphase, mitosis, PMAP, including the prophase, metaphase, anaphase, telophase. We will talk about those. Um, and cytokinesis. Uh, and in the interface, it includes G0, G1, S, G2. In the mitosis, it includes these four phases, PMAT, prophase, metaphase, anaphase, and the telophase. Very complicated, right? Yeah. We will go back to this one. This one is a text summary, but I think it's easier to look at this using this figure, okay? I think that's easier. So let's look at this one. So this is the cell cycle. So basically this cell cycle, let's see, start by G0, G1, sorry, G1, okay? Start by at G1. So G1 is the beginning of the cell. So the cell is like a child, start to grow like in size, right? So G1 cell will grow, from small cell to big cell and to become mature cell, okay? So that's G1, so it's growing phase. G1 can have two direction. One is to become G0. G0 is the one of the matured cell, and it's not going anywhere. It will stay in G0. This is a quiescent state. This is a fully differentiated cell. Like our skin cell, like our nerve cell, like our red blood cell, white blood cells. Uh, so these cells has its function. It's already differentiated from the very immature, like a baby cell, to become one like adult cell with its own destination. A different cell has its own destination. Some cells are supposed to be a neuronal cell. Some cells are supposed to be a heart cell, cardiomyocyte. Some cells would supposed to be a muscle cell, skeletal muscle cell. So when they develop, they will develop into very different shape, very different function. It's like you have your calling, right? You have your destination that you will want to become somebody or someone. And when we are all baby, very much like all the same, right? In the first like elementary school, we are all very much the same, but gradually you will need to find your own calling, your destination. So you will become that. And so same thing as a cell, when they reach their destination, they will stay at G0 and there will be no change. There will be no cycling. They will stay there. So that's G0. Uh, but some other cells, before they will continue to divide like mother, right? So it will, G1 will go into the S phase. So when they go into the S phase, this is destination to move to the division. Cell has intention to duplicate. So in the S phase, the chromosome duplicate here, chromosome duplicate. Chromosome is duplicated, okay? So here we have the, in the beginning, we have 2N, means that one from father and the one from mother, okay? And then here we have 2N, here duplication, so 2N become 2N times 2. So we have, here we have 2N means that we have 46 chromosome, 23 pair. Here we have 46 times 2 chromosomes here in the S phase. So after the S phase, we have duplicate the chromosome, but cell is not divided yet. But in the S phase, we have a lot. I mean, we have duplicate these chromosomes. Then it will go to the G2 phase. So what's this G2 phase for? Before it went into the mitosis, here is the time that it will be divided. When it go into the mitosis, it has go through the G2 phase. This G2 phase is a checkpoint. It's a checkpoint. Check. So here, basically, it will examine all this because now you are going to duplicate all these chromosomes into two new cells. So you want to use, before we do that, we want to make sure that all these chromosomes are healthy, are functional. So here G2 is the double checkpoint. So here we will check, see if there's any like bad chromosome, bad DNA or damaged DNA. So if there's any damaged DNA, we will repair it, or we will kill the cell because the cell is not suitable to be duplicated. If this phase fail, if we cannot double check, we cannot check the damaged DNA and then let these cells to become divided, then these cells has the tendency to develop into tumor. The cells that is not functional and that is duplicated without control. So this is an important step to for our cells to prevent or to allow it to develop like tumor cells. So that's G2. And then we have division, mitosis. Mitosis will have a prophase, metaphase, anaphase, and a telophase. So it's right here. It's all here. And then after that, we will have two daughter cells. Cytokinesis is a separation. After that split, we will have two daughter cells. And then these new cells go through these cycles again. So that's the cell cycle, okay? So G1, so we have the G1 as G2 and the mitosis. So G1 as G2, okay? G1 as G2. G1 can go to S. In S, chromosome duplicated. Or G1 can go into G0, and G0 is a quiescent state that cells find its calling, work on its job, provide its value to our body. Like you find a job and dedicate your life to that kind of calling, and you give up the duplication, something like that. So that's G1. G1 has the two direction. One is going to the G0. G0 is also called fully differentiate cells. So when cells has this tendency to go through this cycle, this cells is called a stem cell. If G1 go to S, G2, this is stem cell. Means that stem cell is the one that can duplicate it, can be divided into more cells. If the cells go into the G0, this is called a differentiate, E-I-F-F-E-R-E-N-T-I-A-T-E-D, differentiated cell. This one is one that is not stem cell. They cannot produce more cells. So here G1, this one summarizes it. Interface, all this is the interface, okay? All through this is the interface. Interface G1 is a growth phase. They produce protein to grow in size. Organelles increase in the cells. So cells from the baby cells to an adult cell. And then G1 has 3 direction. Once it reaches the maturation, it will either continue G1, right? So it will be a longer G1, or it could be going to the S phase. In the S phase, the cell will start to duplicate the chromosome, or going to the G0, the quiescent. And in this phase is for the cell differentiation. So it means that the cells is not like a functional cell, just by a cell. This cell will start to differentiate it. If it's neuronal cell, it will grow a very different shape. If it's myelin cell, it will grow a very different shape. If it's muscle cell, it will grow into a very different shape. Okay, so that's G1. Then G0 is a differentiate. It's a fully differentiated state. Most of these functional cells are at G0. It means that these cells cannot be duplicated. It also means that once it die. The only future is to provide the function to the body, to the environment, and then die. They are not going to be regenerated, okay? They don't have that function. They are not stem cell. Stem cell can regenerate, but these G0 cells, they cannot. We do have the technology to induce then we can provide some kind of condition to a cell. We can take the cell, we can take the skin cell, put into the environment, a lab, and then treat it with solutions. We can induce that differentiated cell to become a stem cell, because this is the cell. They have everything like every other cells. It's just they switch their clock to a G0 and they stay there. We can just switch it back and they will become stem cell. So this is called induced stem cell. So that G0 is a fully differentiated cell. Then S phase. S phase is chromosome duplication. 2n become 2n times 2. So here is the 2n, 1n from your father, 1n from your mother. So this is one of the 23 chromosome. So you have cells with 23 pairs of chromosome. Then in S phase, they will be, each one of these will be duplicated. So these two will be identical to each other. This one, and this one will be identical to each other. And these two are called sister chromatids right here, sister chromatids. Sister chromatids are the exact copy from the chromosome. So we will have duplication. And then these two duplications are not separated yet. It's not mitosis yet. So in the S phase, these two are connected with this structure is called centromere, connect with the centromere. And then we have so this is chromosome 2N, 23 pair. It contains the DNA. And then we have the G2 phase. G2 phase is the one that before the mitosis that we need to check whether all these DNA are healthy or not. So in this check, we have a very important protein called P53 protein. This protein will check the chromosome, this duplicated process, and to see if there's any damaged DNA, they can repair it, or simply just destroy the cells if it cannot be repaired. If this one is failed, then we will let this damaged DNA to become duplicated, go through this checkpoint, and then it will lead to tumor. So that is the interphase G1S G2, and then it go into the mitosis. So mitosis is a phase of cell division. This mitosis include 4 major phases: prophase, metaphase, anaphase, and the telophase. So let's look at this one here, these 4 phases. So this one is G2, it contains duplicated chromosome, and this chromosome usually is not tighted yet. It's very condensed. So in the prophase, we will start to see that the nucleus start to disappear, and we will see that microtubule will form this spindle to these chromosomes. So that's prophase. And we have pro-metaphase and into the metaphase. Usually we don't really pay attention on the pro-metaphase. This is transition. But we have the metaphase. The metaphase is that all these chromatids are aligned here. So here we have the chromatids. Remember, chromatids are connected with the centromere. So here we have these chromatids connect with the centromere. Okay, and chromatids connect with the centromere. So they will be pulled apart. They will be pulled apart. And these chromatids, sister chromatids, are exact copy to each other. So they will be divided, and so these will form a cell, and these will form a cell. And because these chromatids are exact copy to each other, and so these cells will be identical to these cells. So this metaphase, they are aligned and aligned with this called metaphase plate. And then we have the anaphase. Anaphase is a movement, a separation. And then we have the telophase. Telophase is the cells start to pinch off from each other to form 2 cells. And with the cytokinesis, we will start to form the nucleus again to form two new cells. So here is a summary: prophase to metaphase. Prophase, we have the condensation of this chromatin. So it was not very condensed. Now we have to condense. The reason is that we need to enforce it. So when we pull them apart, they will not be damaged. So we need to pack them tightly, and then we will transport them. And then we have the break apart of this nucleus membrane. So the membrane will be disappeared, and these chromatins will then, in the metaphase, these chromatins will then aligned in the equatorial plate, the metaphase plate. So if you look into the microscopic, you will see very like a unique feature that all these chromosomes are aligned in the central portion, central of the cell. So that's metaphase. And then we have the anaphase. Anaphase is that sister chromatids are separated to opposite direction. Telophase start to rebuild the nuclear envelope, and the chromosome is returned back to the uncondensed condition. And cytokinesis is that daughter cells are fully separated. So that is mitosis. That is the cell cycle and the mitosis. So here is a summary that cell cycle include the interphase. Interphase include the G1S, G2, and the G0, okay? And then mitosis, which include the 4 phases: prophase, metaphase, anaphase, and the telophase. So overall, we can usually call it IPMET, IPMET. Taking the first letter of each phases to make it the IP MET. So that's the IP, that's the MET. So the way to, when we have a lab, we would look into this cell under the microscope, and we will learn some skills to be able to identify their phases. So for example, that we may see this is the plant root tip, and we will see some cells are in the interphase, prophase, metaphase, anaphase. You can see that they are separating, and telophase, you can see that they are newly formed. This boundary is still pretty new and relatively small. Or we can see that from this is, I think it's an animal. Yeah, it's a whitefish. So we will also see that this is the interphase. Prophase is all very condensed because, and also it has 2n times 2, has a copy of the chromosome. Metaphase, you can see a line that all the chromosomes or chromatins are aligned in the center. Pull apart anaphase and the newly formed cells. Here we don't see the line yet, but very shallow there will be a line and to separate 2 cells. So that's the phases of the cell cycle. Keep in mind though, this is the cycle we see in the cells that still have the capability to divide. For cells like functional differentiated cell, we won't see this. We will only see this. This will be G0, for that cells. So that's mitosis. That is very typical. That is this one here, mitosis. And another cell division is unique. It's different in the germ cells. That is called meiosis. So this one is mitosis, and this is meiosis. Mitosis, very simple, 2n in the S phase, duplicated to 2n times 2, and then it will divide it to 2n and 2n again. These sister chromatids are separated to form two daughter cells. So that's mitosis. Then meiosis. Meiosis is a little bit, it's a build, it's based on this mitosis, but some details to it. So here is the overview of this meiosis. We have the parent cell 2n, and then we also duplicate it during the S phase. So this one is the S phase, become 2n times 2. So all this chromosome from father and mother, all what we got will be duplicated 2n times 2. And now then we have the first division. So this will be meiosis 1 to form from one cell to form two cells. And then from the meiosis 2 will form from 2 cells to 4 cells. So that basically is the meiosis. There are some detail about this process. We will look into it. So before I want to kind of summarize it here. So here we have 2n times 2. Here though, we will have this division. In this division, this divided sister chromatid. So here we will have exact copy. This one is this cell, and this one is this cell. Is equal. So this one will be all equal to each other. Here though, these two daughter cells, this division is not separated by the sister chromatids. This separation is called homologous chromosome separation. That means that this one will have some father or mother chromosome. This one will have some mother or father. Let's look into the detail later. So, and we will learn that this one is n times 2, means that this one contains sister chromatids, and then here is the chromatid separation. So here has some detail. Let's look into it. Right here, okay? So the meiosis has 2 stages. The first cells has 2n, and then in the S phase, 2n times 2. So this part is easy. The tricky part is the first meiosis and the second meiosis. So in the first meiosis, the separation is not to separate sister chromatids. It's to separate father versus mother. So you have that, let's say you have one mother and one father. Let's use a different color. Okay. One mother and one, why it's still the same color? Okay. So you have one mother, okay, and then one from father. One from father. Yes. okay? And then you duplicate it, right? You duplicate it, the father will be this one here, right? And the mother will be this one here. You duplicate it. And then now it's time to divide. If it's mitosis, it will be that mother here and the father here. All right, and then it will be pull apart. Sorry, pull apart. And then the daughter cell will have these. Sorry, these, and these. So this is one cell. This is another cell, and they are identical, right? So this is the mitosis. As for the meiosis, again, we have this mother, father, right? And the duplicate, right, here. And what happened is the meiosis one is that it will be mother and father, sorry, father. Okay, so it will be like that. And then when they pull apart, we will form father cell and mother cell. So it will be pulling apart, it will be separated, this one will be separated from one daughter, two daughter cells, okay, from two daughter cells. So these two daughter cells, see the difference? When this divided, they divide the sister chromatids. But in the meiosis, the first separation is not to separate the sister chromatids, but they separate the homologous pair. So this one is the homologous pair. So this is the homologous pair. Homologous pair means that you have the same gene, same pair, same chromosome, but one from father, one from mother. You have a pair of it. So that's homologous. And so that is the first meiosis. In the first, these two daughter cells are different to each other. One contains father cells, one contains mother cells. One contains mother chromosome, the other one contains father chromosome. And in the mitosis, the separation is to separate the sister chromatids, and they have equally amounts of father and mother cells in each of these daughter cells. So that is the meiosis. And then, so you remember that you must keep in mind that we have not just one chromosome, right? We have 23 pairs of the chromosome. So we will have these daughter cells may contain this chromosome, or mother cells, or some of these chromosomes to be all father cells like that. So these 23 pairs will contain a mixture of father and mother cells, and the different daughter cells will have different copies of these chromosomes. And then in the meiosis 2, we will then separate these sister chromatids. It will separate the sister chromatids. So that, for example, if that's this one, it will be divided and separated to form 2 cells. And this one will be separated to form 2 cells. So now we have 4 daughter cells, but they are not identical to each other. So we have the chance that different germ cell, different sperm, different eggs will contain different set of DNA. You may get your father's hair, your mother's eye in one of the egg or sperm, and so each one of these will be different to each other. So that's the meiosis. One thing I want to mention about this meiosis is that during this meiosis 1 process, so here we have the meiosis, so this one is meiosis 1 process. When these 2 are aligned before they separate, there may be a crossing over situation going on. So what's happening is that because these 2 are aligned to are very close to each other, so there will be situation that we may have part of this portion to be switched with part of this portion because they are very close to each other. Remember that each one of these chromosomes are DNA, and this DNA are polymer of the nucleotide. So these nucleotides bind with to each other to form this polymer, and they're just by like a kinetic energy, there will be possibility that these 2 may switch to each other, and then we will have crossing over. And the result is that we may come into the situation that we have one of these, and not complete yet, a part of it going here, and then the other one has this portion, and here is the remaining of that. So we will have the crossing over, and then when they separate, we will have the condition that contains a little bit blue here, okay? Sorry, a little bit blue here. I cannot draw it on it, so a little bit blue here, and a little bit red here. Sorry. A little bit red here. Yeah, so that's weird, huh? So that's the crossing over. So that's this one, yeah. The world. So this is the crossing over situation. There may be crossing over in the first meiosis. So that is meiosis. If you ask that what's gonna be in the quiz, right? The quiz will be that common one will be that in which state we will see the crossing over. In which state? Whether that's mitosis, whether that's meiosis 1, meiosis 2, the answer will be meiosis 1. In the meiosis 1, we have the crossing over. In which state, in which phase we will see the sister chromatids to be separated. Sister chromatids. So sister chromatids to be separated, it could be the mitosis or the meiosis 2. Meiosis 2 will have sister chromatids separation. In which state, in which stage we will see the homologous pairs to be separated. It will be meiosis 1. So something like that. So this one is a text, and here is the figure. So here is the meiosis 1, 2N, a line, and you can see that some of these have the crossing over. This separation is separate the homologous pair. And then we have two daughter cells. These two daughter cells, you can see that they are, say, the light from the mother, the blue, the dark from the father. You will see some DNA contains mother, some DNA contains father, and it's not completely father, but also has some portion crossing over, like this one here. So each of these daughter cells will be different from each other. And then we have the meiosis 2 to separate the sister chromatids. So here is a sister chromatid, and it will be aligned and separated. In the end, we have these daughter cells contains only N. The original we have 2N, 2N, here 2N, separated, 2N times 2, and 2N times 2 separated. It will be N times 2. N is the homologous, but this one times 2, this times 2 means sister chromatids. So N times 2, here we contains these sister chromatids. And then we have another separation. We have this is N times 2 and N times 2 here. And then we separate the sister chromatids. This pair will be separated. Then we have N here. So that's the meiosis. Okay, this one just showing you a graph about the comparison of mitosis and the meiosis. We have, in the beginning, we have 2N. During the S phase, we have 2N times 2. So each one of these is duplicated. In the mitosis, these duplications are aligned, and the sister chromatids will be separated. So again, the result is identical to the parent cell. In the meiosis, the separation is not to separate the sister chromatids, but to separate the homologous pair. So the, say, blue from the father, red from the mother, then this first duplication is to separate mother-father. And so we have the daughter cells. These daughter cells contains these sister chromatids, and it's only mother part or it's only father part. The next meiosis separated further to form the daughter cell contains only the haploid of this chromosome, and then it only contains, each one contains N, 23 chromosomes in human. So if we compare this, mitosis only has one division, meiosis has two divisions, meiosis 1, meiosis 2. The meiosis, we have the crossing over, but not in the mitosis. In the mitosis, the daughter cells are identical to the parent cell. In the meiosis, the daughter cells, since the beginning, are different from the parent cell. So this one summarizes the comparison between the mitosis and the meiosis. Mitosis has one division, meiosis has two divisions. Mitosis occurs in the somatic cells. Meiosis is for the germ cell, is in the gamete cells. Crossing over exists in the meiosis. In which phase? In the meiosis 1. Sister chromatids remain together in the first division of the meiosis. So sister chromatids is not separated until the second meiosis. So that's that. Cell phase, cell cycles, and cell division. All right, I need to prepare for the next one. See you next time.